So, lesson 41 talks about reciprocal trig functions. And reciprocal trig functions, you first kind of have to remember back to what the regular trig functions were. And those other trig functions were sine theta, cosine theta, and tangent theta, right? And if I had a triangle written on here, and I put theta on the triangle, as soon as you put down an angle, now you establish sides. Like the side opposite would be which side? The side opposite cannot be adjacent. Or the hypotenuse, right.
The opposite.
The opposite, okay, good. Use a definition with a definition here. It's awesome. The inverse is the inverse, guys. Okay. The other side. How about the side that the angle opens to? Okay. The adjacent is the side that's next to it, and the hypotenuse is always the longest side. Okay? That never has changed. So we got to think back to Sokotoa or some old hippie caught another hippie tripping on acid. And we say sine is equal to what? Opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is adjacent. Okay. So those are the three trig functions that you guys know based off the triangle below. Yeah?
Yeah.
Guess what? There are six total, 3 more of them. And these 3 are cosecant theta, secant theta, and cotangent theta. Now the cool thing about this, CSC, it's cosecant. Now, the cool thing about these ones is in the definition, or the word, or the name of it. It's reciprocal functions. So you got to take the reciprocal, which means take the fraction and flip it. Cosecant and sine are reciprocal functions, so it becomes hypotenuse over opposite. No, reciprocals are not necessary. They keep the same sign. You flip it.
Well,
We flip them. Secant is the reciprocal of cosine, and cotangent is adjacent over opposite. Now there are 2 more ways, and then guys, you can still use the same exact triangle. Now here's the thing. I don't remember, personally, cosecant, secant, and cotangent as in opposite over, or hypotenuse over opposite, hypotenuse over adjacent, or adjacent over opposite. I just remember the main 3, and then know that I need to take the reciprocal. That's how I remember it. So this thing right here is not needed to remember all of these. I remember the first 3, take the reciprocals. Now, what I do need to do, I'm going to take that out of here, because I need the space, is that we also need to realize that these can be written other ways. We can say that sine of theta is equal to 1 over cosecant theta. Cosine theta is equal to 1 over secant theta. And I'm running out of room. Tangent theta is equal to 1 over cotangent theta. Okay? But that's not it. They can also be flipped in their own way. Because wait, there's more. We could say cosecant theta is equal to 1 over sine theta. Secant theta is equal to 1 over cosine theta. And cotangent theta is equal to 1 over tan theta, or tangent theta. It looks like there's a whole bunch of stuff and different things going on, but it's just about taking the reciprocal. It matters because eventually you're going to have to expand or simplify or prove things are the same, and you're going to need to know how to switch these around. So, everybody has those? So, what's going to happen now? Well, what's going to happen is I'm going to go like this. Sine of theta equals 3/5. Yep. I'm going to give you this, and I'm going to say, find all 6 functions. Find all 6 functions. Now, if you were to look in the book, and they start to introduce the sine, cosine, tangent, cosecant, secant, and cotangent, they list them all from top to bottom, all 6 stacked on top of each other. And then they go, oh, the first one and the fourth one are related. They're reciprocal, so they draw a line to it. And then they go to the second one and the 5th one, and they draw a line, and so forth. It's confusing. This is how I suggest you do this. I suggest you write it down. Sine theta equals cosecant theta equals secant theta, or not secant, sorry. I want it to say cosine theta equals secant theta equals. Last ones, tangent and cotangent. I'm not leaving myself very much room here. Then you just put in what you know. What do you know?
Sine.
You know sine. What is sine? 3 over 5. Which means you also know
You also know
cosecant, which will be 5 over 3. Now, we got to figure out the rest of them. To figure out the rest of them, build yourself a triangle. So I'm hoping this isn't going to be too tough. Put in theta. I don't care what theta is. I really don't. But I do need it to say, this is where I'm coming from. And so therefore, you know sine. What's sine? 3 over 5. You can find the third side by using Pythagorean's identity. Or theorem, sorry. I'm thinking other identities for trig. 5 squared equals 3 squared plus something squared. Or 5 squared minus 3 squared. 25 minus 9, which is 16. Take the square root. It's hopefully we start to recognize that 3, 4, 5 triangle comes up. This is not a reference triangle. We do not have a reference triangle that is a 3, 4, 5. It's one of the special Pythagorean triplets, though. And so now, using theta, which is not changing on us, what's the cosine? 4 over 5. So therefore, the secant is 5 over 4. Tangent? 3 over 4. Which is? Boom. Not so bad. It's not that bad. What happens, though, if I gave you this?
Pi r, like pi 18 or something.
Let's do,
It's supposed to be cotangent theta.
oh yes, cotangent theta, sorry, yes. Cotangent theta of, let's do
How do we do
2/7. Find L6.
3/7?
Yes. So, again, just write them all down. I'm going to try this time.
Which then would tan
Sine
be
theta.
7/2?
Cosecant theta. Cosine theta. Secant theta. And tangent theta. Cotangent theta. Which one do we know?
First
Cotangent. We don't know the first two, we know like the last one. 2/7. So the tangent is 7/2. Now what we need to do is form a triangle. Okay? So we put our sides in. Which one is where? Two goes over here.
7 on the bottom.
And now you have to find the hypotenuse. 2 squared plus 7 squared equals, we'll call that H for hypotenuse squared. I don't know. Really, it doesn't matter.
It's always C.
It's usually C, but I'm using something different. Broaden your horizons, guys.
L1.
Emma?
Are you going to secant tangent for the triangle?
Secant tangent. I gotta find H or the hypotenuse so I can find the other 4.
No, I'm saying for the triangle, right?
Remember, tangent. Oh, guys, is that what you're saying? The 7 and the 2 are mixed up.
Yeah.
Guys, I messed up. I messed up. The sides are wrong.
Oh, I knew it. That was terrible.
I'm writing in pen.
We never write in pen.
Opposite over.
It's opposite over adjacent. I put the cotangent in instead of the tangent. Right. So be careful. Hey guys, here's the cool thing. My 2 squared plus 7 squared doesn't matter because the order doesn't matter. So that's cool. So I get 4 plus 49, which equals 53. Not 59, 53. Right? So then it becomes H is equal to the square root of 53.
That's right. What is that? It's like.
But would you just keep it?
We're going to keep it as square root of 53 because I can't simplify square root of 53. You can't make a factor tree. You can't go to the dance, remember? So, what's the sign of this then?
7 over square root of 53 or
7 over square root of 53. Or it would be 7 times the square root of 53 over 53 if you rationalize it. We're not going to rationalize for now. You guys can do that, so I'll give you time to get your work done. Cosecant then would be? Yeah. Cosine would be? And square root of 53 over 2. You guys got it? It's not so bad. Homework. Directions are find all 6 functions of number 1. Cosine theta is equal to 2/3. 2 tangent theta equals 1. And the third one, cosecant theta is equal to 8/3.